This section is about horizontal asymptotes and what that definition is, as well as how you find horizontal asymptotes. The first part is the definition. A horizontal asymptote would be a y== equation because it's a horizontal line. And it is another way of talking about horizontal asymptote is the end behavior. As x goes out to infinity, is the function approaching a value? That would be an asymptote. Or as x goes out to negative infinity, is the function approaching a value? It is possible for a function to have no asymptotes. If the end behavior is infinity, then your function would have no asymptotes. It would be possible for your function to have one asymptote, either because both ends are approaching the same number, or because one end is approaching a number and the other end is approaching infinity. It would also be possible for a function to have two different horizontal asymptotes, one to the right and one to the left. Can't have any more than two because a function only has two ends, the right end and the left end. I also want to emphasize one more time that a function can touch its horizontal asymptote. Some tools for finding these limits, for finding the value of a horizontal asymptote, one really useful tool is using 1 over x as a building block. We're familiar with that 1 over x graph. The 1 over x graph is the one that is a hyperbola, and in both directions, that graph approaches 0. You can also use dominant terms to find limits. Higher exponents are going to have a greater impact on your y-coordinate. Regardless of what the coefficient is, the higher exponent will have more impact on the y-coordinate. Exponential functions have an even greater impact on the y-coordinate than any exponent. However, only in one direction. The e to the x graph starts off very, very small and then shoots quickly up to infinity. So as you're going out towards negative infinity, e to the x has almost no impact and would not be a dominant term. But as you're approaching positive infinity, e to the x is a dominant term, even more so than like x to the 10th would be. In rational functions, these are just some examples of how to deal with those. The first function, f of x, the degree is the same. If I look at just the dominant terms in the numerator and the denominator, my dominant terms are the ones with the largest exponents. The degree here is the same. So this function, as I take a limit out to infinity, this function negative 9. Oh, I reduced that. Negative 3x cubed over x cubed, and then the x cubes cancel. So the asymptote for this function is y=-3. For g of x, the degree in the numerator is larger, and that means that I have no asymptote because my numerator is growing faster than my denominator, so I do not have an asymptote. For the first one, the asymptote is y=-3. For the second one, there is no asymptote. And for h here, the degree in the denominator is larger, which means my denominator is growing faster than my numerator. So this asymptote would be y. Here's an example of finding horizontal and vertical asymptotes. I'm going to encourage you to pause and then come back and view my solution. So pause now. So the horizontal asymptote, I don't have to do any factoring of any kind. I just look at my dominant term. So the horizontal asymptote would be y=1/4. The vertical asymptote, I do want to factor, and I notice that I have a hole. At x=5, I have a hole, but there is a 0 in the denominator at x=-5, so that would be a vertical asymptote. It's possible for a function to have two different asymptotes, and so here's an example of a type of function that has two different asymptotes. The absolute value of 2x minus 9, the dominant term would be 2x. And then if x is going to infinity, I know that 2x is going to be a positive number, so the absolute value function is not going to have any impact on that. It would be 2x over x. So this would be, the horizontal asymptote would be at y equals 2. However, if I go to negative infinity and I do that same process, I have to keep in mind that x is a negative number, so 2x would be a negative number. When I put 2x inside of the absolute value function, I need the effect of the absolute value would be to change its sign so that this would be positive. I don't change the sign in the denominator, that would still be just an x, but now my asymptote is at y equals negative 2. Here's what that looks like graphically. I can see that I have a horizontal asymptote at y equals 2 in the positive direction and at y equals negative 2 in the negative direction. When you have exponentials, remember those are dominant as you go out towards infinity over any exponent, but they're not dominant as you go to negative infinity. So this first one, as I'm going to positive infinity, I would look at 6e to the x over 3e to the x, because the e to the x would be dominant, so there would be an asymptote at y equals 2. And then if I look at going out towards negative infinity, these terms are going to be basically 0, and so I have 2 over negative 4x to the fourth would be my dominant terms. And so this, in the negative direction, my asymptote would be at y equals 0, because again, my degree is higher in the denominator. Here's a picture of what that graph looks like. I just want to show you this graph in particular because it crosses one of the asymptotes, and that's okay because all the asymptote is telling us is the end behavior out to infinity, so it's totally fine for it to cross the asymptote somewhere in the middle of the graph. This is another example with exponentials, and you can see that as I go out towards positive infinity, e to the negative x is going to have basically no impact, so this function, as I do the limit as x goes to positive infinity, becomes y equals 3, would be that asymptote. And then if I go out in the other direction, I have the limit as x goes to negative infinity of e to the negative x over x, and that would be a negative number because e to the negative x would be positive, but x would be negative if I'm going out to negative infinity. But it really, I have a higher degree in the exponential function is growing much faster than the y equals x function, so this is no asymptote in this direction. When our functions have radicals, it actually behaves a little bit like those absolute value functions I was talking about. If I'm going out to infinity, I square my number, I take the square root of that. I'm going to look at just at dominant terms here, so I have 9x squared over 3x, and as I'm going out towards infinity, I square x, it becomes positive, but it was already positive, so the square root would be 3x. And so this function would have a horizontal asymptote of 1 in the positive direction. In the negative direction, when I look at the square root of 9x squared over 3x, I square x squared, and then I take the square root. I'm going to get a positive number. I'm going to get positive 3 times the magnitude of x, but x was negative originally, so this would actually be the absolute value of that 3x. Both of them actually would be the absolute value of 3x. But if I'm going to negative infinity, then this would be y equals negative 1, because x is a negative number, so the absolute value of that would change its sign. Here's a graph of that function. You can see that out towards positive infinity, that graph is going towards positive 1, and as x goes towards negative infinity, that graph is going towards negative 1. You might also notice the vertical asymptote that happens when x is equal to 0, which makes sense because there's a 0 in the denominator that you can't factor out. The last problem here is just a chance for you to practice understanding what this behavior means. So I'm going to pause again, or encourage you to pause again, and then come back and see my solution to this, keeping in mind that there's definitely more than one function that fits this criteria. Graph passes the vertical line test, so it is a function. And if your graph has a horizontal asymptote in the positive direction towards -3 and a horizontal asymptote towards 1 in the negative direction, and if it has a vertical asymptote at 0 with both ends pointing up, then you succeeded on this challenge. All right, thank you so much.